Hello everyone, welcome back to the Decode. I am Dasanpriya and this video we are going to learn graph representation using an adjacency matrix. I will explain what an adjacency matrix is, how nodes and edges are represented, good thought, a simple example, and finally discuss the advantages and disadvantages. So let's get started. What is a graph? Before talking about adjacency matrix, let's briefly understand what a graph is. A graph is a data structure that consists of the vertices, also called nodes, and edges, which connect these nodes. Graphs are used to represent real-world relationships such as road networks, social networks, computer networks, and many more. To work with a graph in a program, we need to represent them in memory. One such as method is a adjacency matrix. Definition of adjacency matrix. An adjacency matrix is a two-dimensional arrays used to represent a graph. If a graph has n vertices, then the adjacency matrix will be of size n by n. Each rows and each column represent a vertex. The value stored at position I, j tell us whether there is an edges between vertex I and vertex j. How nodes and edges are represented. Let's understand how nodes and edges appear inside the matrix. If there is an edges between two vertices, we store 1 in the matrix. If there is no edges, we store 0. For weighted graph, instead of 1, we store the weight of the edge. In an undirected graph, the matrix is symmetric because the edge from A to B is the same as from B to A. In a direct graph, the matrix may not be symmetric. Now let's look at a simple example. Suppose we have a graph with 4 vertices A, B, C and D. The edges are A to B, A to C, B to D, C to D. First, we assign a index number to each vertex. A equal 0, B equal 1, C equal 2, D equal 3. Now, we can create a 4 by 4 matrix. If there is an edges from A to B, we place first at 0, 1. If there is no edges, we place 0. After filling all values, the matrix clearly shows which vertices are connected. Let's briefly talk about weighted graph. In a weighted graph, each have values such as distance or cost. In an adjacency matrix, instead of storing one, we store the weight of the edge. For example, if the distance from A to B is 5, then matrix A, B will be 5. If there is no edges, we usually store 0 or infinity, depending on the application. Now, let's discuss the advantages of using an adjacency matrix. First, fast edge lockdown. Checking whether an edge exists between two vertices takes constant time. Next, simple and clear structure. Easy to understand and implement. Next, good for dense graph. When a graph has many edges, adjacency matrices are very efficient. Next, useful for graph algorithms. Algorithms like float visual use adjacency matrix directly. However, adjacency matrices also have limitations. First, high memory usage. A matrix always requires n by n space, even if the graph has very few edges. Not efficient for sparse graph. When there are few edges, most values in the matrix are zeros, wasting memory. Next, adding vertices is expensive. Increasing the size of the matrix requires rebuilding the structures. Finally, to summarize, an adjacency matrix is a simple and powerful way to represent a graph. It works best for dense graph and situation where fast edge checking is required. If this video helped you, don't forget to like, share and subscribe to the Decode. Thank you for watching and I will see you in the next video.
Panda. I got broads in Atlanta. She took the lean in the family. Credit cards and the scammers. Hitting the